A quiet night sky can feel safe and familiar. It looks the same for many years. A comforting canopy of distant, silent lights. But on one otherwise ordinary night, a team of scientists found something that broke that silence. They recorded a strange signal from far away in the cosmos. This signal was not like the usual radio noise that fills the universe. It did not behave like a known star. It did not behave like a familiar planet. The strange whisper from the void made people stop what they were doing. It made them lean in and listen very, very closely. The signal came from a dark patch of space, traveling for an untold number of years before it arrived at a radio telescope on Earth. To understand why this signal was so startling, you first have to understand how we listen to space. We use giant radio telescopes, essentially enormous curved dishes, like a TV satellite dish, just on a grander scale. They collect faint radio waves across light years, focused onto a sensitive receiver, then converted into data a computer can analyze, like catching raindrops, except they're invisible waves of energy. These telescopes let us map the radio sky, which looks very different from what our eyes see. Usually the data is a noisy, jagged line, the background hiss of the universe, distant galaxies, clouds of gas, even the remnant heat of the Big Bang. Known objects like pulsars show repeating spikes, a cosmic drumbeat. But this new signal was different. In the dark, unusual for transient cosmic events. An invitation to a great mystery. When the team confirmed it wasn't a simple glitch, Dr. Eris Thorne gathered his colleagues.
We need to tear this observation apart. Be our own harshest critics.
They divided into groups. One team recalibrated every instrument, receiver to digital recorder. Every cable checked for flaws. Software audited line by line to rule out artificial patterns. Classic reboots. Off, then on. Another team mapped local radio activity, satellites, stations, radar. They modeled reflections, off the moon, off space debris, anything that could fake deep space. After weeks, they concluded. Not equipment, not terrestrial, not orbital. The signal remained, real and persistent. Only then did they ask for help. With internal checks complete, Dr. Thorne's team alerted the global community, sharing data and methods cautiously. Independent verification began. Point every instrument to the same dark patch. From Chile to Spain, giant electronic ears listened. Radio plus multi-wavelength allies, optical, infrared, X-ray, gamma ray, joined the search. Several radio observatories confirm the same narrow band tone with the same complex pattern. But in visible light, nothing. X-ray, only a faint, diffuse glow. Normally, radio-loud sources are tied to bright things, quasars, supernovae. Not this time. Preferential radio emission became a crucial clue, narrowing hypotheses. The mystery was bigger than one team, but now it had a chorus of eyes on the sky. First suspect, pulsars, spinning neutron stars with clock-like beams. But the tone was too smooth, too long, and the repetition too complex. FRBs, powerful and brief, milliseconds. This was a sustained hum, as if an FRB slowed down and held a note, something they don't do. A black hole in a binary, an accretion disk and jets could beam a steady signal. Persistence and complex changes could track orbital motion. Plausible, yet none fit perfectly. Nature is more clever than we are. This is the exciting part. when observations push theory to its limits and force new ideas. Could it be human-made? Satellites, communications, radar? Parallax and sky position suggested a far more distant fixed source. Third-order reflections, Earth to Moon to debris and back, simulated and rejected. The provocative idea, an artificial signal not human. Scientists tread carefully. The wow signal was narrowband too, but never repeated. This one persisted and repeated. Extraordinary claims require extraordinary evidence. This signal alone isn't enough. The team discouraged sensationalism. History turns aliens into pulsars and quasars. Science demands patience. The data, not hopes, must lead. No grand claims, just data. Frequency, strength, pattern, verification steps. Methods and raw data published for the world to test. Others analyzed with different algorithms. Fresh eyes, new patterns, replication across instruments. Then a breakthrough. Subtle Doppler shifts, toward us, away from us. Evidence for orbital motion, supporting a compact object in a binary. A black hole or neutron star companion became compelling. Science advances by accumulating clues, self-correcting toward truth. Man-made ideas faded. A new natural object, perhaps a unique binary, took the lead. Today, on October 10th, 2025, the story isn't finished. Consensus leans toward a rare binary, likely involving a compact object, perhaps a neutron star or a small black hole with beamed radio emissions. Doppler shifts are strong evidence for orbital motion, but science doesn't run on most likely. It runs on proof. We need to pinpoint the source and the physics behind its broadcast. The search continues, more focused than ever. Keep watching the source, refining its orbit and pattern. New instruments like the Square Kilometer Array will boost sensitivity and detail. They may reveal an accretion disk, a jet, or something else entirely. Each observation, a new page in a cosmic story. Even if it's a new kind of star, it's a tremendous gift. It reminds us, the universe is full of surprises. Even in well-studied skies, new phenomena hide in the noise. It pushes theory to the limits, new possibilities for matter and energy. It expands our knowledge of the cosmos. Solve one puzzle, find better questions. From a single blip to a global investigation, curiosity, method, wonder. For those who look up, there are still so many secrets. Follow this story. Read the observatory updates. Look at the data, often public online. The universe speaks with physics and light, sometimes a whisper, sometimes a strange, beautiful song.